First of all, kids do come to it with enthusiasm.
We have it, we have it, we have it.
They're having conversations about what they're doing, and I can listen and get a real sense of their reasoning, of their problem-solving skills, of their approach to an activity.
Then that turns off 20 because it's a multiple. Because
4 is a multiple.
Yeah, because 4 times 5 is 20.
Yeah, 4 would. So now we have, yeah. Okay, so we do 2, 5, 4, I think. Let me try that.
Press the 2 first instead of the 11. Yeah.
Yep, 2, 5, 4.
Okay.
Got that?
8 will flip on 16.
Would we need to press 1 because isn't 17 a prime number?
We start by really just using the language of Sketchpad to help them understand the language of math. A line versus a line segment. A point versus a collection of points. Defining geometric shapes by the vertices. Then we work them into forming polygons, and then we work them into whatever the content for that grade level is.
We have been studying the ancient Romans, and we've just been doing mosaic tile designs in Sketchpad that are based on real mosaics that were found in villas in Britain. So there are a lot of opportunities to bring Sketchpad into the whole curriculum.
You can go to construct and create arc through 3 points, and it would make that. Then you select the whole thing, double click on the dot there, and do, what's it called? Rotate. And it'll create another one of these, except rotated, and you do 90 degrees. And then you do reflect, which would give you this.
Well, some of the great activities for middle school with Sketchpad include just things like line and angle relationships, area. We use Sketchpad a lot for deriving and understanding area formulas. Our students also use it for modeling problems. For example, we just did an activity where students used Sketchpad to model the effect of changing the angle of the solar panel as it's facing the sun. So as the angle changes, the band of sunlight that it's capturing increases or decreases.
Another big project we do that is transformational project, where they go in, learn how to do translations, rotations, dilations, reflections in Sketchpad, and they have to create a sketch that has all the transformations in it, and they have to include an animation. And there again, I've gotten just amazing things.
It really is a much more efficient and effective way of demonstrating many of the mathematical big ideas. We actually move more quickly through the curriculum because the models are so strong in Sketchpad, and the sketch work brings out so many big ideas simultaneously that the teachers have been able to streamline their teaching because the examples are so broad and so enriching.
Moving along a number line is something that's very familiar to students. Now, when you see the number line on the textbook, there's no motion involved, and so you're not bringing in that sort of embodied understanding that students have of moving. We want to get our rabbit to 12. So lots of different ways of getting our rabbit to 12. Kids will often want to take one jump of 12, which is a very good way of getting the rabbit to 12. And kids think this is very funny to see the rabbit take such a long, big jump to 12. How else could we get to 12? So some students might start thinking about, well, one jump of 12, maybe we could do 12 jumps of 1, and that would be a natural way to go. And it's bringing out the structure of how this multiplication works for factors of the number 12. We're going to jump by 6 2 times now. And what we're doing as we work with all these numbers is we're not just listing all the factors of 12, which is a common task that is given to students. We're getting this visual representation of what we might call the factor family of 12.
The number and operations, working with positive and negative numbers and measurement as well.
The calculator really brings kids back to quantifying things that they're doing. We did a lot of measuring of things in the classroom, going around with tape measures, finding round things, but we also went to Sketchpad and measured circles and set up a table and began to see that pi could be derived very precisely using the Sketchpad calculator.
Often the mistakes are smart mistakes, it gives them some idea what they weren't thinking about in the right way. While it may be the wrong path, it often helps them find the right path better, and not just because it negates what they were doing.
Wait, yes it does?
No, it doesn't. No, it's not, Jonah. Look.
It looks to me like it's staying something, but it's not staying a square. Right?
Yeah, it's staying rectangular, but not a square.
Yeah.
I show them pre-made applications that have been provided through the Geometry Sketchpad website. I also use the lesson link, and we talk about different ways that we can integrate that in the K-6 classroom.
Like, there's one thing with elephants, you have to get them all in a fence with only 5 lines, and it tells you how long they can be.
I'm in a middle level classroom, so in my classroom we use it a lot for transformational geometry and for coordinate plane geometry. We can define lines, we can look at slope, we can look at how slope changes, we can look at the basic transformations, and it gives the students a really great dynamic way of seeing the motion in the coordinate plane for the transformation.
And the most challenging of all is having children construct their own version of circles and squares and work independently with friends. And that's where numbers can really get crazy, because children can construct things that are more difficult than teachers could ever dream of. And you'll often see children doing all kinds of circles and squares configurations with all kinds of numbers to try to stump their friends.
So I came up with an idea, and I demoed it to the kids. I wanted them to understand why the grid worked. Gave them directions on how to construct a right triangle, and then they were to connect the dots and give me back something like a teapot. I got back the most amazing things from that project. I got the school mascot, which was a Spartan. We got Elvis played on the sides of a right triangle. Tweety Bird. They just absolutely loved it.